Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 70. The topic is removing cloud providers from the zero trust equation. Our guest today is Fabian Kamel, senior consultant at Control Plane. Welcome, Fabian.
Thanks for having me.
Maybe before we dive into the topic at hand, Fabian, you could just tell us a little bit about yourself and what you do.
Yeah, hi, I'm Fabian. As you said, I'm a senior security consultant with Control Plane. I live in Germany. I worked 5 years for Bosch, so a big automotive player. Was managing PKI and public key infrastructure, doing stuff like automated software updates. Then I took a quick detour into confidential computing, where I worked on like a confidential Kubernetes distribution. And now I'm with Control Plane for almost 2 years now. In general, making the cloud native space a lot safer than it was yesterday.
And maybe you could just tell us a bit about Control Plane. I think they're one of the sponsors and hosts of SOCON, the FOSDEM Fringe event in London that's coming up in February. But what does Control Plane do?
Yeah, as I said, so we're a cloud native security consultancy. We're helping a lot of folks in regulated industries, so that'd be like finance or medical institutions, to get their security right. A lot of them are new to the cloud native space. So yeah, there especially with like secure architectures, but also pen tests. We run, for example, the Capture the Flag event at KubeCon. And as you mentioned, we're very active in like local conferences in and around London, but also in general, all over cloud native.
Cool. So the topic today is around SPIFFE. And, this is a topic, this live stream audience are identirati, so people who know more about identity and access management. But SPIFFE is sort of a tangential related, area. But maybe just for our audience who doesn't know that much, could you give a quick overview of what is SPIFFE?
Yeah, definitely. So as I mentioned, the cloud native space has a lot of different systems, right? We have like different cloud providers, but we also have on-prem systems. We maybe have mobile phones out there or like IoT devices, and all of them should communicate securely with each other, right? But in order to implement secure communication, you first need to be able to identify all the parties involved, right? Is this a human user? Is this a database in AWS? Is this like a laptop on some desk, right? So identity is really the first step. And SPIFFE helps you in these heterogeneous environments to give all of these different identities an identity, but also a provable identity, right? You can use different properties like IP addresses or residing in a cloud provider. And then, the SPIFFE framework helps you to create these so-called SVIDs, so ID documents, which you can basically use as a passport to prove who you are. And then on top of that, you can implement very secure authorization solutions.
At a high level, is SPIFFE about making MTLS less painful?
Yeah, you can say that basically, right? Because MTLS in and by itself isn't that hard, right? We can get free certificates if we want today. So the only difficult decision really left is like, should I grant this entity access to the endpoint or the system or whatever it's asking for? Like, should I trust the party on the other end of the connection? And again, like this comes down to like, who is this person, right? If I know I talk to Mike, then it's easy to make that decision, right? I can chat to Mike, I can give him access to certain information. But even in this day, or especially in this day and age, right? Mike could be anyone. He could use Gen AI and be a cat on the internet, right? I have no idea if he really is who he says he is. And if we have provable identities, then that problem gets a lot easier.
Now, you mentioned an acronym SVID, which stands for SPIFFE Verifiable Identity Document.
Exactly.
Can you tell us a little bit more? What is that? What is an SVID?
Yeah, so as I said, I like to compare this to my passport, right? It's like a standardized document, so you can write software against it. It has like key information that identifies the entity in question, and then it's signed by a trusted authority, and that's the important piece, right? Somewhere in our system, we have basically the brain of our authorization operation, and this brain is able to create these SVIDs, right? Assigning or issuing these documents, just as your local government is the only party that is allowed to issue like passports. And then once you have your document, you can go around in your environment. You can go to your AWS microservice, show your SVID, and then the service knows how to talk to you, how to authorize you. And the same should hold true if you use it to talk to something on-premise or some other part of your very heterogeneous network.
The idea that SVIDs are a SPIFFE verifiable identity document, it's a little bit weird to hear identity applied here, because we're not talking about a human identity. We're talking about an identity of something that's presenting an MTLS certificate for authentication, which is generally a web server. Do you think the use of identity here is really appropriate?
Yeah, I think so. I don't think we need to define this as an either or, right? Even in MTLS, it can be both. So I have used MTLS as a human talking to a web server. That works. In the end, you will still be identified as this person. In MTLS land, this will be X509 certificates, right? You can store these on your local machine or a smart card, stuff like that. And then the server can validate that you are really you based on the certificate information. And it's very equivalent in SPIFFE Spire land, this SVID. Right? Instead of an X509 certificate, you have this.
When you talk about being personally identified, like I have a smart card, and this has a chip on it that has a certificate that's been issued by a CA, and so I can make an MTLS connection with this smart card to prove my personal identity. But that's not the type of identities we're normally talking about here. With SPIFFE, I don't have a SPIFFE ID as a person. SPIFFE IDs only apply to workloads. Would you say that's accurate, or maybe could you use a SPIFFE ID for a person?
Yeah, they're very flexible, right? There's nothing in the SPIFFE standard, as far as I'm aware, that prevents this. In the end, they look very much like a URL, right? And you can build this identifier however you see fit. So if you want to identify a different set of people, you could certainly choose a naming convention and do that.
Now, an SVID is generally an X509 certificate, but it could be a JWT, right?
Yeah. So the standard is very flexible in the technologies you want to choose in the end.
So at the point at which you're minting a JWT, it sounds awfully like OAuth, doesn't it? We're signing a JWT and sending it across domain for verification and trust. What's the difference, I guess, at that point between a SPIFFE JWT and an OAuth access token?
Yeah, I think the big advantage of SPIFFE is just that it's a lot more flexible. So you are free to implement a system that supports whatever entities you have, right? It'll be very difficult to give your database an identity in OAuth land, right? Or even single instances of a microservice, their own identity in OAuth land. You could certainly do it, but it'll be quite difficult to do so.
I'm not actually sure that I agree with that. In OAuth, we have these things called software statements. This is presented by the issuer to clients. So if you're a developer, let's say we say, okay, here's a software statement. It's a signed JWT, and you can present that to perform dynamic client registration by calling the dynamic client registration API.
Yeah.
That SSA is verified by the authorization server, and then you're issued a client credentials, a client ID, and normally at that point you're registering with a private key. So it sounds like there's a lot of overlap. Is the issuance of SVIDs also dynamic? How does that
Yeah.
work? If I'm a client, how do I actually get an SVID?
Yeah, I think that's the part I was alluding to, right? I think that OAuth is technological like fit to do this, but SPIFFE helps you to identify these very different technical entities out there. So as I mentioned, right, you could be a database in AWS, or let's say like an EC2 machine, a VM in AWS land. Then SPIFFE helps you with a certain set of software to identify this VM securely, right? It can gather meta information that only exists in AWS. It can ask AWS for you to like verify that this machine actually exists, and it can embed all of these information in the client identity in the end.
Right. Yeah, I think you're jumping ahead a little bit. I did want to talk about confidential virtual machines, but
All
before
right.
we get there, I'm just sort of fleshing out because it's sort of I'm fascinated by these overlaps between sort of different domains and how they've come up with similar solutions, and I see a lot of sort of pattern matching between OAuth and SPIFFE. What I think SPIFFE maybe does well is that because it uses X509 certificates, which is not a format supported by OAuth. In fact, I believe they really wanted to avoid any more over reliance on the X509 standard. That actually they avoided that, but because SPIFFE actually supports the X509 presentation, it's able to write on top of the MTLS authentication mechanism. So I was trying to make a comparison. Is the SVID a software statement, or is the SVID the client credentials? And I think actually the SVIDs are more like the client credentials themselves. And in a way, one of the improvements I see is that they already are short-lived certificates, so they sort of enforce key rotation.
Yeah.
But what do clients do during the bootstrap process to register? How does the I forget what it's called. There's a component in the SPIFFE architecture that the SPIFFE workload API, I guess, is the thing that issues these SVIDs. How does the SPIFFE workload API know that it can actually trust this client who's asking for an SVID?
Right. Yeah, I was mentioning this very briefly in my last answer, right? So you have this server, right, which is basically your brain of operation, and it's very powerful. But the thing that also helps in the SPIFFE architecture is the so-called agent, right? So let's like draft up a quick like example architecture, right? You have like a VM where you want to deploy like some microservices, right? And all of these need an identity. Instead of each microservice having to talk to the server, the brain of your operation, we deploy the agent locally on the VM, right? So that makes the implementation a lot easier because then you have this local thing you can talk to. But the first thing that has to happen is like this agent needs to authenticate to the server, right?
Mm-hmm.
The agent also has an identity. If we now assume like we're running on a VM, then this agent assumes the identity of that whole VM we're running on. It gathers some information about itself. As I said, in AWS, that would be like, there's this AWS metadata you can gather as a VM and ask like, who am I, basically, to AWS. And they send this to the server. This information is already signed by AWS. So the server can verify this, right? And say, like, yes, you're already a VM running in my account, running in my zone. And then it authorizes this agent to mint these SVIDs, right? And then, as you said, this workload API comes into play, right? Where the workloads can talk locally on the same VM to the agent. And
does the agent actually mint SVIDs, or does the API manager, the SPIFFE workload API, actually mint these SVIDs?
Yeah, the workload API is available on each agent. right? And it's the only interface that your workloads have to interface with, right? They don't.
So the
care what
agent is
happens.
locally issuing these SVIDs, not relying on the central issuance of the SVIDs.
Well, it's still talking to the server, right? But from the perspective of your workload, it's only talking to the locally available workload API.
And the agent, I'm just curious, is the server actually signing these SVIDs and generating these certs? So the server is still involved. The agent is just providing the local interface.
Yeah.
Okay.
There's still a backend connection between the agent and the server.
Yeah. In OAuth land, we'd call the agent the client. This is one of the challenges, is that there's no overlap in the jargon. And and you're saying that the server knows it can trust the agent because during registration it says, "Oh, I know this VM. This is part of my network. Therefore, I'll allow it to register." So the trust is sort of bootstrapping off the fact that you know that this is your server, and it's based. Is that based on the host name? Like just based on the host name, I know I control this host name. How does it actually work?
Yeah, that'd be a bit too easy, right, for an attacker just to fake a host name. But this is actually where SPIFFE or Spire is not trivial to actually implement in a real world environment, right? The whole security of your system is made or broken by how strong this authentication of the agent actually is, right? It gets stronger the more metadata we gather about this VM, right? We can gather like, I have this IP address or this host name, right? All of these single points are very easy to fake, but if you gather enough of these data points, it's very difficult. In addition, you can also fall back on third parties, right? As I said, in AWS or in every major cloud provider, you can request to get like an identity document for your instance, right? Then AWS basically, again, signs a certificate with some information or over some information that says this VM actually is owned by this AWS account. It is using this, I don't know, operating system version. It's running in that zone. And you just continue to gather a lot of meta information that in some are very hard to fake by an attacker.
Okay, that makes a lot of sense to me because in OAuth, in dynamic client registration, sometimes you provide an attestation. In fact, there's an OAuth standard for attestation-based client registration. For example, similar to what you're describing, Google and Apple both have integrity APIs. So if you download a mobile app from the Play Store, then Google Integrity API will tell you, well, the checksum is the same on this device as it was on the Play Store, so we know the app hasn't been hacked. But it will also provide information about the device, like what type of operating system it is. Has the phone been rooted? If the phone's been rooted, maybe you don't even want to let this app register. So it sounds like what you're saying is that during the SPIFFE registration process, the client or the agent obtains an attestation, in this case from Amazon or the cloud provider, and that attestation itself is trusted and allows the agent to register. And at that time, does the client actually present a public key for future identification?
Yeah, so it gets a unique identifier in that whole agent and server bootstrapping phase, but it's not directly generating like a PGP key or what you're thinking about.
Okay, so I'm sorry, but OAuth's actually better because OAuth, when you register, you do present a public key for future authentication. And then B, in addition to providing attestation, OAuth allows you to provide what's called a software statement assertion, or SSA, which is a JWT, which can be verified and might say, what type of client are you? let's say you're a bank and you have a CRM app and you have a mobile banking app, and you don't want the CRM API calling the bank API. So you might have two different software statements, so that when the app registers, you want to know that this app registering or this agent registering can only register for a certain subset of capabilities. So it's a way to convey trust from the center to the thing that's registering, other than the attestation. Um, anyway, it's really fascinating. Let's dig a little bit deeper. So the Google Integrity API is actually an interesting example, but we don't have a Google Integrity API here. This is a virtual machine. Tell me a little bit about what you found out about how confidential virtual machines can basically improve the quality of this attestation, this machine attestation.
Yeah. Yeah, as I mentioned, in order to put trust in this virtual machine, right, we basically ask Amazon to tell us this VM is genuine, right? They say like, yeah, of course, this is a VM that comes from us. But in that case, we now need to trust AWS to not be malicious. In addition, we also need to trust the fact that there are no attackers powerful enough in the AWS network to fake this information, right? And I don't want to pick on AWS, right? This goes for any cloud provider, any hosting provider, right? We just started with AWS as an example here.
or even an enterprise running their own.
Yeah.
I mean, I think the question that you're asking, and that's sort of interesting, is that when you're running a VM, if somebody maybe has root on the host computer or has root access to the VM, that you maybe can't trust that VM, even if Amazon says it's a good VM. Is that what you're saying?
Exactly. And the infrastructure stack today is like, it's very big, right? It's not just the actual VM and the operating system you're running, right? But below that, there's proprietary cloud management software that each of the big players have. They're like different hypervisors. There's the BIOS. There's like, even the CPU is very malleable, right? They can put like microcode updates to patch things like Spectre to a certain degree, right? So there are all of these different attack vectors, and all of them have a direct impact on the security of your system, right?
I think a lot of people are so siloed these days that we forget that there's an actual server there running maybe something like a hypervisor, giving us VMs, and that VM thing might be giving us VMs. And we're so disconnected.
VM is a thing.
From the hardware and infrastructure that we forget how this stuff actually works. But so I guess, we like to think that when I get a VM, that's a unique thing. But what you're saying, though, is that if we get some type of hardware assertion and we have VMs, maybe that's the same hardware assertion for all of the VMs. So how do we actually know that if I'm running on the same CPU, physical hardware, but I have 15 VMs, how do we know that each VM gets its own unique, let's say, machine attestation?
Yeah. So the only thing we can be certain, right, is if we properly separate these different VMs, and like we have a new technology that is called confidential computing, which basically gives you all of these nice memory separation guarantees, right? They came into like popular recognition like maybe 8 years ago or so, when Intel SGX was first introduced, right, where you could isolate a single process in your operating system and do some interesting stuff in it in a very protected environment. But since then, this concept has been extended, and now you can get a full confidential VM. So the full virtual machine context is moved into its own memory encrypted environment on the host machine. So it means that even the person who is renting out the VM to you is not able to look into the memory you're accessing. They don't know what you're computing, right? What you're holding in memory. And that's really the first time where the cloud makes sense, right? Because you can rent a VM from someone and be certain that you're the only one who has access to that VM.
Right. Now, I was reading about this, and one of my concerns is that not every CPU actually supports this hardware. do you have to know what type of hardware you're actually running on, and request certain, maybe like, kernel flags or something? Like, how hard is it? It's hypothetically possible. I mean, I could see how ideal it is that you know that you're the only one who can see that data in your VM,
Yeah.
but how hard is it in the market to actually get the right hardware and deploy this type of network?
Yeah, if we would have had this conversation like a year or two ago, I would have said very hard. But in the meantime, it's gotten a lot easier, right? So if you go to the big three cloud providers, AWS, Azure, or Google, it's a checkbox. It's like when you create a new VM, you scroll down enough, and they have their own wording, of course, but you just tick the box, and you get one of these confidential VMs. Of course, as you said, there are some limitations. Not all CPU types support these. So you need to check the cloud vendor's documentation to see which machine types actually do support it. But yeah, from then, it's super easy to get one.
So trust goes beyond just the tools, like SVIDs or OAuth. I always say you need both the tools and the rules. And so it's not just the tools for, okay, so now we have these machines that can, that can register themselves and assert, this is an Amazon instance, and, and I can assure you that you're running in a confidential encrypted session that only you can see. But we still need to develop tools that enable us to say, okay, which Amazon domains do I trust administratively? Like, how do I set up one of these? Let's call it a federation. And also, in order to get trust, we need the rules. So we need the ISO and SOC, policies and evidence. And also, if we're involved in interdomain transfer, we need maybe even legal agreements. So can you talk about maybe how this technology is part of a larger trust ecosystem to really establish trust for something like this stack?
Yeah. So I think the interesting bit about confidential computing is that once you have one of these VMs, you can ask the CPU to basically give you a report about the state of your confidential VM. And it includes like a hardware fingerprint. And you can use, this is deterministic, so you can calculate it beforehand, right? And you can compare this, as you said, like the hard part is always the policy part. Is the thing I get really the thing I expect? And then I need this inventory of expected and valid things. But once I have it, I can spawn the VM, get the fingerprint. It's signed by the CPU, right? We can verify it. And then once we compare it to the policy values we have in our database, we know this is a trusted VM, and there is no like rootkit or like any software added during the boot process. How this fingerprint is calculated, it's basically measured boot on steroids, I want to say. Right? It starts very early in the boot process and covers a lot of things from like the earlier stages of creating the VM up to the point where you like put the operating system on it and like any additional software. Right? You can measure all of these components and be sure that only what you ask for is included. Right? And that's a very strong guarantee, as you said, for things like government frameworks, right? They want the assurance that you know what's running in your system, and now you have this hardware generated fingerprint of like, this is what's running in my system.
But let's just use the government example. So if I'm a government, I want this, but if I implement a process, do the sort of admin tooling exist to really take advantage of these capabilities and give me reports? Or it's like I see this as the last mile, but now that the last mile is doing this, do we have the actual enterprise sort of tool set that we need to say, okay, what are my trust domains, my SPIFFE trust domains, and can I generate reports to show compliance? Like, how does the admin tooling and sort of trust management side of it look? Or is that still very ad hoc at organizations?
So You're asking in terms of confidential computing? I don't think there's anything special about confidential computing per se.
Or
Just gives
more
you
in terms
another
of
guarantee.
the SVIDs in general. So now we have these higher quality SVIDs that include the confidential computing, the confidential VM information. So now we know we can trust this VM, um, and but well, let's sort of move to the next phase of this. How do we know what processes we want to trust on this VM? Like, how do we have a good identifier, but how do we sort of manage how we want to provision? This is a database server and it should maybe only doing database things, or this is a web server, it should be doing web things.
Right.
What's sort of the next level of management now that this infrastructure is in place?
Yeah, I don't want to become the person that is just throwing around buzzwords now, right? but this is the point where security needs to become holistic, right? As you said, like confidential VMs now give us the capability to have this fingerprint, but then how do we know what the expected value should be? As you said, like how do we know what should go into our database server, for example, right? This is where things like reproducible builds are helping a lot, right? And these have grown, support for these have grown over the last couple of years, where you can basically define as software what goes into your server. And then once you know this, you can generate the fingerprint in advance. And when you then send the ISO or whatever machine image have you to the cloud provider, spin it up, you get the fingerprint back, you can compare this to the one you have computed locally, right? That's a very, very strong guarantee.
Where have you seen this used? Are customers actually adopting it? Have you seen any real world use cases?
So this is very, very new technology, right? There are a few startups out there who are working on products in the space of confidential computing, or like building new exciting products that take advantage of this technology. But yeah, like the highest the companies with the need for very high security are definitely taking advantage of this. We have seen use cases to do like distributed learning on big data, for example, right? These so-called data clean rooms, for example, where different companies provide like medical data, very sensitive information, and they should only be processed in these confidential VMs. So we can be sure that no one else has access to these. Right.
Do you know what the business driver was for them? Like, why did they say, I mean, because a lot of times, why was this such a high priority that they had to do it?
So for the medical example, right, it's like we see there is a lot of power in doing like big data or like AI type of applications on like medical data, right, where you can predict diseases a lot better. But at the same time, a lot of countries are very concerned about like what happens to the medical data, or like even in a single country, right? It's very difficult to share these information. But if you can prove that no one really has access to the data itself that goes in, but only the result that comes out in the end, it's a lot easier to work with these regulations.
There's a new working group at the IETF called the WMSI Working Group. It's the Workload Identity Management. Have you heard of that, WMSI?
No, I haven't.
I think that there's people who are active in both SPIFFE and OAuth are working in it, because I think there is some acknowledgement that there's some overlap between these two technologies, and also the passkey FIDO world, I think, has contributed some like real world experience into how attestation-based enrollment and authentication works. So yeah, I think it'll be interesting. One of the overlaps that I see is that I think SPIFFE has been mostly in the cloud world, whereas OAuth has been more in the web and mobile app world. I think that, for example, the idea of a confidential VM doesn't really exist for a web application or for a mobile app. or it's just different. I think mobile app does have a pretty close example with the integrity APIs, but
Yeah.
Whimsy is looking to sort of maybe combine some of these ideas into a common vocabulary and set
Yeah.
of standards.
So
Um,
again, like SPIFFE Spire is exactly the use case is that you're not just in a single cloud, right? Because if you only subscribe to one cloud provider, they usually have their own identity solution that works very well with their own services, right? SPIFFE Spire
hmm,
shines if you have different cloud providers, but you can also have on-prem or like very, very different identities that you somehow need to bring together and still be able to also authorize them. And even on mobile, it would be totally doable to give your mobile app an identity. And then is the question, like, how do you verify it, right? You have the same hardware assisted capabilities in smartphones, right? You have ARM trust zones, for example, if you want to do something comparable to CVMs, also a slightly different version of the same beast. We also have TPMs in our laptops, right? And SPIFFE does support using TPMs to enroll a device. So it's a very, very flexible system in that regard.
right, right. I guess if you're saying that we don't need a virtualized system, considerations go away when you are actually running on the hardware and you have a TPM or a
Yeah,
secure element of some kind. But the idea
exactly.
is pretty much the same. Have you seen SPIFFE deployments for mobile applications? I haven't personally seen that a
No,
lot.
I don't
Yeah,
think I have.
yeah. I've only seen SPIFFE in the cloud context. I mostly see it with a mutual TLS.
Yeah,
And I think it's relieving a lot of pain in the MTLS area. And the idea that SPIFFE uses certificates is really useful for MTLS because one of the issues I think that's challenging is client key rotation. Um, and it seemed like SPIFFE SVIDs handled this by using short-lived certificates. Um,
right.
so that's one advantage I see over this over OAuth, whereas
Yeah,
SPIFFE, the server side is sort of in control of the length of the certificate and how long it's good for, whereas in OAuth, you're reliant on the client to do key rotation and then to update its registration that it has a new public key.
yeah,
So that part of it is very interesting. Um, it'll be fascinating to see what happens at the Whimsy work group as some of the SPIFFE community and OAuth community intersects and collides and comes up with something new. That's quite a new work group, though. This isn't like OAuth where they already have tons of RFCs. The Whimsy work
mhm.
group sort of at the same level as OAuth. It's a whole new working group working on new drafts, and they're starting from scratch.
That's
This idea of
interesting. I definitely look into it.
this idea of workload identity is really taking off right now. We're seeing. What do you think is the right word for this? I've heard non-human identity, workload identity, software identity, code identity, machine identity. What's your preferred way to think about these things that aren't human?
Yeah, it's difficult, right? I think workload identity makes sense for most of the stuff we have out there, but I really don't want to exclude the human as well, right? We have a lot of interesting use cases where both humans and machines need to work together, and somehow these systems also need to be able to model this, right? So,
Right.
like,
Although we have a lot for humans, though. We have OpenID Connect, which defines ID tokens, identity assertions for humans. We
right,
have all sorts of tools for humans. I think the challenge that the enterprises are seeing today is that the same level of tooling that exists for humans doesn't exist for non-human identities. And a lot of
yeah,
these non-human identities have privileged IDs. So they're calling databases or calling APIs that are potentially more sensitive than what normal users or have access to.
yeah,
So Yeah, yeah. If you could pick a term, am I hearing workload?
I think I would
like
go with workload. Yeah, it seems to
Um,
fit the best for me.
I personally like workload the best. I feel like none of the terms are actually good. I don't like non-human because I feel like, well, the list of what's non-human is infinite. You know, my mouse is non-human, but like everything's non-human. So I don't like defining something with a negative. Um,
But how do you talk MTLS to your mouse then if it doesn't have an identity?
no, I think that my mouse should have an identity, but my coaster also doesn't have. It's all. This is also non-human. Everything's non-human. The list of things that are non-human is infinite. So I just think it would be better to say what it is than what it isn't.
Yeah.
So yeah, well, that's I think, though, that we're seeing sort of a renaissance of companies in the identity management space taking a new look at how do we manage these entities that are not humans but might be acting on a human's behalf, like an autonomous AI agent. Maybe that's waiting for the airline tickets to drop for you so it can buy tickets, or dating for you or something. As one of our previous guests suggested.
That's a whole different set of problems.
Yeah. But we might have a number of these non-human identities, including workloads, enterprise processes and other things that are doing things and have their own identity. And this is where I think SPIFFE has been playing sort of a very sort of embryonic role in defining solutions for how to manage this requirement around non-human identities. I guess we should move to last thoughts. Any last thoughts before we break?
Yeah, I think just to linger on the workload bit, right? Even if we stick to one term, right, it's often very difficult to draw like a neat box around the identity you have, right? We mentioned we have like a VM that could be an identity, and then you have microservices in it, and like how deep and how fine-grained do you go? So if you're looking for an authorization solution, you really need something that is flexible enough to model the rather messy real world.
Yeah, well, I like ending on that note because Glue is episode on December 17th. We'll be announcing. It's the 17th at noon. We have the Cedarling launch. So Glue is launching a new authorization product, and one of the ideas is to be able to make policies about this new information that's coming in about trust, like how trusted is the workload. Well, this is a really interesting topic. Thank you so much for joining us.
Thanks for having me.
I'd like to quickly remind the audience to subscribe to Identity Office Hours on LinkedIn. We're trying to get to 1,000 followers, at which point we'll be able to stream directly, and we'll get all sorts of other great privileges. So please click on the Identity Office Hours link and just hit follow. The next episode, actually, we have a Australia episode coming up, Connect ID 1 year on. So Connect ID is a Australian identity service that I think a lot of Identity would love to know more about. And we have Andrew Black and Dima Pasnikov will be our guests next Thursday, this coming Thursday. So I hope you can join us. So thanks, audience. Thanks again, Fabian, for joining us. And
anytime.
We'll see you next time.
All right.